Okay, what science lesson doesn't need a dramatic intro? It's lesson 19, and in a moment, you're going to see some additional evidence about the asteroid collection mission, and that's going to prompt us to investigate a bit further. You'll need a pencil, today's journal slip, your science journal, and some materials that you see on your screen. So here's an email from Central Command. They analyzed the thruster data from the pod, and it says right here that they found out that the thrusters exerted the same strength force as in other missions. That's odd. If the thrusters fired with the force that they usually do to stop the pod, then why didn't the pod stop? There must be some other cause. Well, it does say in here that the pod had been collecting asteroid samples. Could a difference in the number of asteroid samples explain why the same thruster force caused a different change in velocity? Take a moment to think about that question and record your ideas on your journal slip. To see if the asteroid samples made a difference in how the pod's velocity changed, let's do an investigation. In this investigation, you're going to need your launcher. That represents the thruster force. And your bottle cap, that's representing the pod. And some coins, that can represent the asteroid samples. Now, I used pennies, but you can use any coin that's going to fit in your cap. How do you think we can see if the number of asteroid samples affected the pod's velocity? Think for a moment on how you could plan a fair test. You're right. If we apply the same thruster force to the pod of different masses, we can observe any changes in velocity. But how are we going to make sure we apply the same thruster force every time? Well, you need to make sure that in this investigation, you pull back to the same marking every single trial. All right, you're all set up? Ready to go? First, let's observe the velocity when the ACM pod has no samples. Pull back the rubber band to your marking and observe how the pod moves, its speed and direction. Do this a few times so that your observations are consistent, and write your observations in your data table. Do this now. Next, test the ACM pod with a light load of asteroid samples. To do this, I added one coin to the cap to simulate a light load. Now, pull back to the same marking to be sure you're applying the same force, and watch the speed and direction of the pod now. Do this a few times. And what do you notice? When you write your observations, you'll want to start comparing the velocity of the different pods. Does this one move faster than the pod with no samples? Does it move slower? Does it move in the same direction or a different direction? Take a moment to explore and do this now. Okay, now you're going to test the ACM pod with a medium load of asteroid samples. I added 2 coins to my bottle cap to simulate this. Remember to pull back to the same marking and then watch the velocity of this pod. Do this a few times and then record how the speed and direction of this pod compares to the others. And finally, test the ACM pod with a large load of asteroid samples. I added 3 coins to my bottle cap. Pull back to the same marking and compare the velocity of this pod to the other ones. Write down everything in your data table. Okay, it's time for the sense-making part of the investigation. Look back at your data. What pattern do you notice? Why might 2 objects be affected differently if the same strength force is exerted on them? Answer now. For today, I need you to submit 2 things. 1, submit your journal slip. And second, submit a video clip of a trial where you were testing a pod that actually had asteroid samples collected. A trial where you were exploring the pod with the coins in it. Until tomorrow, keep thinking, keep learning, and we'll explore this relationship a little bit more with a computer simulation in an upcoming lesson.